Right. So in this question, we need to integrate, find the integration for this question. We have two fractions here. And usually if you have, for example, if you have two fractions, usually to be able to add them, you need to find the common denominator, make them both have the same denominator. So, for example, if I say just to remind you of adding fraction, if we have 2/7 plus 5 over or 3/7, yeah, if both of them have the same denominator, the same bottom, we just add the tops basically. So in that case, it's going to be 5/7. But if they have different denominator, say we have 2/7 plus 3/5, and I want to add them, we can't say it's 5/7 and we can't say it's 5/5. We need to find the common denominator. So in that case, the common denominator for them is the 7 times 5, which is 35. So that will be, both of them have the common denominator, which is 35. And then you find like, it's like 2 times 5 is going to be 10, plus 3 times 20, 3 times 7 is 21. And the answer for this example is 10 plus 21, which is 31/35. This is just to remind you of how to add fractions if they have the same denominator or different denominator. Okay? Right. Now we go to our, sorry, back to our question. We have the denominators here are different. So basically we need to find the common denominator for them. And the common denominator for them, if you guess it before I say it, it's x squared sine squared x. Okay, so so that means I can write this as x squared sine squared x plus this x squared sine squared x, okay? And x squared sine squared divided by sine squared is x squared, so it's going to be x squared times 1 plus cosine x. And then this one's going to be sine squared x multiplied by 1 plus x, okay? So if you, well, I'm going to go through it in details. So that's going to be, write it down here. It's going to be like x squared times 1 is x squared plus x squared cosine x over x squared sine squared plus this sine squared times 1 is sine squared. Okay, so this is going to be sine squared x plus x sine squared x over x squared sine squared x. You don't have to do all this. This is too much details. You don't need it. So now it's like we are doing x squared over x squared sine squared plus x squared cosine over x squared sine squared. So this is going to be 1 over sine squared. Yeah, I'll just do example of them maybe, because it takes time. Like I will do this one here. It's like x squared over x squared sine squared x plus x squared cosine x over x squared sine squared x. So you cancel this x squared with this x squared and this x squared with this x squared. So what we get here, after you do all for all of them, you will get 1 over sine squared x plus cosine x over sine squared x plus, now the other fraction, when you work it out, you will get it as plus 1 over x squared. So I did this, yeah, plus 1 over x squared. There's going to be 1 over x squared because you have sine squared, you have sine squared here and sine squared from the bottom, you will cancel them. So you'll get 1 over x squared plus, and now you have like sine squared over x squared sine squared. So the sine squared will be cancelled and you end up with plus x over x squared. I mean, it's 1 over x actually in that case, it's going to be, yeah? So this is like 1 over x. Right, so next step, it's going to be, this is all like we are integration, we are doing the integration for all these. Right, so this is going to be 1 over sine squared x, which means 1 over sine squared is cosecant squared. It's cosecant squared. And the cosine over sine squared, it means cot times 1 over sine, which is cosecant. So plus cot x and cosec x, because 1 over sine is cosec, plus x to the power minus 2. This is this one here. And plus x to the power minus 1. Yeah, so that's so far just simplifying this way. And yeah, so let's put the dx. And then this is going to be equals, the integral for cosecant squared is minus cot x. That's from your formula sheet. And the integral for cot cosecant is minus cosecant x. And minus cosec x. And the integral for x to the power minus 2 is minus x to the power minus 1. And the integral for x to the power minus 1, yani the integral of 1 over x, which is ln x. So plus ln x plus c. And that's it. So I equals, that's the integral. Okay? You okay with this? Right. Now, okay, so differentiate, just for you to remember and put this idea in your head. Like when we differentiate, we always multiply, and when we integrate, we divide. So if we have a function raised to the power n, then we will multiply by that power, and we take away 1 from the power. So if, for example, if we have d over dx for x to the power 5, then we will do multiply by the power. So we'll put the 5 down there, we will multiply by the power, and we'll take away 1 from the power of x. So 5 minus 1 is going to become 4. And when we integrate, we do the opposite. We will divide by the power, we will add 1 to the power and divide by the new power. So if we have the integral of x to the power 5 dx, we will add 1 to the power, so this is going to become x to the power 6, and divide by the new power, which is the 6 here, and plus c. Okay, just want you to remember which one is which. Don't mix up, yeah? It's a shame if you mix up in the exam and instead of you integrate, you do the differentiation. So differentiate, we multiply, and integrate, we divide. We've seen already a special case of the chain rule. If the inside function is linear, when we differentiate, we must multiply by the coefficient of x. So if we are doing d over dx for a function, a linear function, that means ax plus b, so it's linear, it's not squared, etc. Then we multiply by the coefficient of x, and we, well, for these kind of things, you don't take the power anyway. So d over dx for e to the power 5x minus 6. We know the derivative for e to the power x is, it stays same as it is. If it's the derivative for e to the power 5x, it's going to be e to the power 5x as it is, stay, but we multiply by the coefficient of x, which is the 5, yeah? So I would expect this to become e to the power 5x minus 6. You will put it as it is and multiply it by the coefficient of x, or the derivative for 5x, which is 5. And therefore it is 5e to the power 5x minus 6. The second one, d over dx for the sine 3x. The derivative for the sine is cosine. So I will write it as cosine 3x, then multiplied by the coefficient of x, which is a 3. Okay. The derivative for the tan is secant squared. So tan 6 minus x, as it is going to be secant squared 6 minus x. And the derivative for the 6 minus x is going to be minus 1, because the coefficient for x here is minus. Oops. The coefficient for x is minus, so it's like minus 1. So this is going to be secant squared secant squared 6 minus x, right? That's here. These are the answers for them as well. I hope this is clear now. Right. So that's when you differentiate, you multiply, and for the power, you take away 1 from the power. When you integrate, when we integrate, we do the opposite. As I told you, we add 1 to the power, so it's opposite to the differentiation. You add 1 to the power and divide by the new power. So in this case here, the integral of e to the power 5x minus 6, as I said, the integral and the differentiation for e to the power thing, it's same as it is. So in this case, it's going to be e to the power 5x minus 6, as it is, divided by the coefficient of x, which is 5. So this is going to be e to the power 5x minus 6 divided by 5, which is 1 over 5. The sine, the integral for the sine is minus cosine, yeah? So it's going to be minus cosine 3x, and then you divide it by the derivative for the 3x, or the coefficient of x, which is 3. So it's minus 1 over 3, or minus cosine 3x over 3. Okay, the integral for the tan is well, it's, we know that, we don't know this. This is going to be from the formula sheet. So it's minus ln, yeah, minus ln secant. So it's going to be minus ln secant 6 minus, sorry, it's ln secant 6 minus x multiplied by the coefficient of x, which is -1. So that's why we get the minus here, right? Rewrite this again. It's length secant 6 minus x times -1. So that's minus length secant 6 minus x, right? And again, these are same thing, plus c. Did I put the c there? Plus c. All of them need c because it's integration here. Right. Happy about this? Okay, what else we need? Let's see. This is your turn. Yeah, if you want to feel happy, then it will be really good for you, everyone,